Okay guys, today we're going to continue with our similar triangles and recognizing them on graphs. So, remember, just like small thing to recall, if I have the same slope, that means my proportions are the same, which means I'm going to have similar figures. So again, if I look at these triangles, A, B, C, and then A prime, B prime, C prime, these look like similar figures because their shape is the same and their size is slightly different. The way that I figure this out is I set up proportions, or I set up ratios, which is a comparison of two proportions. So 5:10, if I reduce that down to its simplest form, by dividing by 5 on both sides, that becomes 2 to 1. So our proportion there is 2 to 1. Now, if I set up 7 and 14, because those are corresponding sides, if I divide by 7, again, my ratio simplifies down to 2 to 1. So since these are the same, these triangles are proportional, and they are also similar. Let's move into our steps. Okay guys, there are some steps to determine if figures are similar. So here they are. Given points, you're going to have to plot triangles. None of our examples, I'm going to have you plot triangles during this video just because that's not a skill that we need to work on. We're going to do that once we get to guided practice. The second step is to find the slope of the hypotenuse, find which is the longest side of the triangle. And third, if the slopes are the same, the triangles are proportional. So let's say I had a graph, and I graphed this small triangle and this large triangle. Now, as long as their slopes of their hypotenuse come out to be the same, then the triangles will be similar, but they both have to have the same slope. So if I had a slope of this triangle of 4, this triangle must also reduce to 4 for its slope in order for them to be proportional. So let's do an example. Okay guys, let's look at these triangles and try to figure out if they are similar. Alright, so the way I figure that out is I find the slope of the hypotenuse. The hypotenuse of this triangle is t prime to s prime, and the hypotenuse of this triangle is s to t. And all I want to do, again, is figure out the slope. So let's do triangle SRT first. So I'm going to find the slope between T and S on this triangle. And this is just very simple rise over run. So let's see how many times I rise. 1, 2, 3, 4, 5, 6. A rise of 6 and a run of 1, 2, 3, 4. Now, if I reduce this down to simplest terms by dividing top and bottom by 2, I have a slope here of 3/2. So SRT has a slope of 3/2. Now, triangle S prime, R prime, and T prime is much larger. So its slope is going to be different, but as long as it reduces down to 3/2, the triangles will be similar. So let's test it. Okay, now I'm going to find the slope between T prime and S prime. And again, this is just simple rise over run. Again, I like to write out rise over run because it helps me keep it straight. So let's see how many times we rise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have a rise of 15 and a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And a rise of 10. Now, if I divide this down to simplest terms, by dividing top and bottom by 5, I see that this has a reduced proportion of 3/2, or a slope of 3/2. So, since these triangles have the same slope, they are proportional. Let's look at what an exemplar response would look like for explaining that. Are the triangles proportional? Enter your description below. Sometimes you guys are going to see this. Enter your description below. It just means write out your explanation in the space provided. The triangles are proportional and similar because they have the same angle measurements and proportions but are different sizes. That is my answer. I know this because I found the rise and the run or slope of the hypotenuse in both triangles. That's my explaining my calculation. Since both triangles had a reduced proportion of 3/2, the triangles are proportional. And that's my explanation. Make sure that your explanations also include all components of our ACE framework. Let's go ahead and practice, guys.